Alright students, so this is page 100 of the notes, and this is paired data or dependent sampling. So in what's often the case is you have a sample and you take these, it's usually subjects of some sort, and you collect data from them, and then you give them a treatment, and then you collect data from them after the treatment. That's the most common case that you'll encounter with dependent sampling, and it's often known as the before and after study. Now with the before and after study, or the dependent sample, we have to look at the mean of the differences, because we'll have the befores and we'll have the afters, but we have to kind of try to combine it. So we're always going to want to test to see if the mean difference is either greater than 0 or less than 0. Okay, so our hypothesis will always be about the mean differences. And we usually won't have a two-tailed test. Usually we'll be wanting to know if there was an increase or a reduction of some sort. The critical value, if you're doing critical value method, will be a t with degrees of freedom of n-1. And a test statistic, we're going to be using the mean of the differences and the standard deviation of the differences. And again, degrees of freedom in your critical value is n-1. If you're doing the p-value method, then you need to do a t-test. Okay, so let's do an example. This is example 9.1, and it says, does counseling help reduce anxiety? A study was done and the results are as follows. We're going to be using a level of significance of 0.01. The higher the score here, so the higher the score in here, the higher the anxiety level. So the first thing that we have to do is calculate the differences. So what I've done is I've simply subtracted 121 minus 76 equals 45. 93 minus 93 equals 0, and so on and so forth. Okay? So I've just calculated the differences. And what we need to do is we need to get the mean and the standard deviation. If you're using the critical value method, you're going to need those things. So in my calculator, and I know I've brought up an 83, but if you have that little blue and you know how to do your one variable statistics, that's all we're going to do. I like these graphers because they have a large screen which you can see. I've entered the data already, and so I'm going to bring up one var statistics, and you can bring that up in the little blues as well. But I need to know the mean, which will be the x bar, and the standard deviation, which again, remember, is SX in the Texas Instrument calculators. All the Texas Instruments use SX. So we're not talking about X, we're talking about the mean of the differences, D bar. According to my calculator, that's equal to 33.33 repeating. And I'll use 2 decimals here to try to keep it simple for you guys, because I don't need to have a super amount of decimals floating around, I suppose. 9238, 4 decimals. I can bring this mean to 4 decimals when I get ready to use it. And this guy is the standard deviation of the differences, or S sub D as we'll denote it. Okay? Now we need to set up our hypothesis. Our hypothesis will be the mean of the differences equals 0, meaning there is no difference, and that's always how it's set up in the alternative. The mean of the differences is 0, there is no difference. Now we need to pick an alternative symbol to indicate that anxiety was reduced and counseling did indeed help. Okay? So this one's tricky, and I messed it up the first time that I did it. You have to really think about what we're doing here. We're subtracting the befores, and then we're saying before minus the after. So if the before score is high and counseling is indeed helping reduce anxiety, their after scores will be lower, thus the differences would be positive. Here, in this case, where counseling does not help this individual, the difference is negative, so that If it's not helping, it's less than 0. If it is helping, it's greater than 0. So we need to set up a greater than 0 symbol. Okay, and that's the trickiest part. That's probably the hardest part of the whole problem. And you know, I messed it up, so don't feel bad if you thought, whoa, that just totally blew my mind there. Find a critical value if you're doing a critical value method. So you're going to be using a t with an alpha in a one-tail area with 8 degrees of freedom, because we had 9 subjects total and degrees of freedom is n minus 1. Now let me show you on the t-table in case you've forgotten. It's a one-tail area, so you scroll over and you find 0.01 on the one-tail area, and you scroll down to your 8 degrees of freedom. Right? And that's where that number is coming from. Now, we've got a one-tailed right test, so we need to shade the right tail and label it our rejection region, 2.896. Graphers, if you're doing a p-value, if you've got an 83 or higher and you want, like the critical value method, that's okay. You can do a t-test. Okay? You can do a t-test for dependent samples, and you can use data. And mu naught will be equal to 0. List 1 is where I had my data stored, and I was doing a right-tailed test. Calculate. There's the p-value right here. It also gives us our test statistic, so let's try this test statistic and see if we get this value. It's a great way to also check your work. So if you should ever need to do the critical value method, or maybe you just kind of like it because it is kind of soothing in its own way, the grapher is also a great tool to check your work. So let's plug in dbar for the critical value method and get a test statistic so we can know what kind of decision to make. So it's the dbar, the sample of the differences, minus mu sub d, which is 0, according to our null hypothesis. The standard deviation is 22.9238. We're going to divide by the square root of n, and n is 9. We need to do that in our calculator, and preferably make it very clean and work well. So I'm going to use parentheses, just like I put in my work. And give me just a moment to calculate that. 4.3623. And I'm looking back at my calculator to see what its test statistic was, and it was 4.323. Look at that. Isn't that nice? We calculated the test statistic, and I know there's a glare right there, isn't there? And the calculator is backing us up. It says, yeah, that is your test statistic. Exactly, because the p-value depends on that test statistic. So our test statistic is falling in our rejection region, so we will reject H naught. Now p-value, guys, if your p-value is less than the level of significance, the alpha level, then you reject H naught. And it is, and so we also reject H naught if you're doing the p-value method. So either method, you're going to come out with the same decision, and you're going to come out with the same conclusion. Let's write our conclusion. Based on the evidence there is or is not, we're rejecting H naught. So we're going to say is a significant reduction in anxiety after counseling at the alpha level of 0.01. And that is probably what we box on our worksheets, yeah? Okay, so that was a dependent sample. Again, we got to use a t-test, and again we have to use the differences, and that's the only thing that makes it a little bit different from mu and sigma is unknown, is we've got to use the differences. So we have a little extra preliminary step in there. Otherwise it's just the same. Feel free to use either the critical value method, which I always set up in my notes, but I also teach the p-value method because while I believe that the critical value method is a great foundation to start learning on, since I use the p-value method in work and in my own mathematics, I like to show you both. Okay, so good luck, and if you have any questions, let me know.